So I guess the first thing I see here is we have the same navigation bar at the top.
Hmm. Yeah, and it's kind of makes a lot more sense in the context of this leader's schedule. We'll drag it around here. And so um, here it's really controlling the entire interface on this screen. So here I'm dragging it into the future. You can see we're in the future. And so what we're seeing is the leader schedule at that point in the epoch. So 10 hours and 21 minutes from now, we can see that, Galaxy has a leader rotation. And we can also go back in time and see people that have had leader slots. And here we're able to see these leader slot. There was, 8 hours and 9 minutes ago. So this is really kind of how this epoch slider connects to the interface. It's a nice way to navigate around. But yeah, if we're kind of viewing this live view, we'll see the network kind of progressing through slots in real time.
And essentially adding together, combining the votes and non-votes should match the transaction count we saw that was essentially making its way through the TPU waterfall.
Yep, exactly. Yeah, and that'll be what's reported as the transaction count on a block explorer if you were to look at one.
Right. And the green check marks are indicating not that it's processed and not skipped ticket.
Yeah, so there's a bit of information here. This check mark is kind of a fun one. So it starts out a little hard to catch it, but so it starts out processing, which means the slot is in progress. So the slots recall are 400 milliseconds. Immediately after it completes, which means this node we're looking at has finished replaying it, it goes that hollow green, which you can kind of see flashing. But what you'll see mostly here is the solid green, which means it was optimistically confirmed. That means I think 2/3 of the cluster voted on that slot as being valid. So it's almost surely going to be included. It would be a slashable offense for it to not become part of the chain, as a validator would have to switch their vote in violation of the rules of the system. Here we're actually going to see us produce a block. This is our node. Okay.
Yeah.
But yeah, so you can see the network is optimistically confirming slots really, really quickly, like well under a second. And if you scroll down, you'll actually see there's another state here, which is rooted. So this happens after about 12 or 15 seconds. So that's what this kind of little Rubik's Cube thing is showing, that these slots that were optimistically confirmed are rooting pretty soon after. So yeah, that's that little icon. And then we have just a bunch of other information about the slots that are being produced. Again, you have the number of votes and user transactions, aka non-votes, in the slots. You can see the leader who's producing it, what software they're running, how much stake they have, what their IP address is that they're publishing the block from. And then we have a little bit of economic information about the block. This is the fees and the tips.
Yep.
These are the fees and tips that are owned by this validator. So the tips are after the commission paid to the block builder. You can mouse over these and see the specific amounts if you're interested.
All right. Yep. And these are net to the validator then?
Yeah, net to the validator and their stakers. So the fees are fully net to the validator. The tips will be split with the stakers depending on the tip commission. Then we have the duration. This is kind of the most useful one, although the hardest to understand. So we'll come back to that right after. Compute units, which is very straightforward. This is the number of compute units in the block. This will never, at the moment, exceed 50 million because that's the limit on block size. So you can see most of the nodes are doing pretty well filling their blocks. The chain has a lot of traffic right now. Here's an old version of a Firedancer that's capped at 48 million still. So yeah, the compute unit's kind of useful. You'll see sometimes occasionally, the Gavi schedule is not perfect. Now there's a Firedancer one. So sometimes a node will not completely pack a block. Here we're at 71 for this agave node.
So looking at that and seeing, say, something below 95% on occasion isn't really cause for concern.
Yeah. Yeah, in general, I think a lot of what goes into the blocks is not economically useful to the validator, meaning it doesn't pay very much. Almost all of the fees are coming from the top, let's say 5 or 10% of the block. So when you see this, even though a bunch of transactions didn't make it in that could have, it really likely hasn't affected your validator revenue at all. So although we don't like to see this for the chain health, it's not super alarming as a validator. I think you shouldn't, immediately go and be like, oh, I need to get all of these to exactly 50 million.
But if an operator is seeing consistent, let's say consistent performance below 90%, that could be an indicator to start thinking about upgrading
Yeah, yeah, and
hardware in
like,
that case.
yeah, and here's a node in Agave 2.1 that, has done a
Yeah.
20% and a 15%.
Mhm.
Like if I saw that, I'd kind of maybe start to think a little bit about, looking into that.
And then you could so you can filter this for your validator slots
Yep,
as well, right?
yep. This is kind of the most useful one. So here we've filtered it to just our slots. If you had skipped any slots, you could filter just to those skipped ones.
Mhm.
But here we're filtering to our slots, and we can scroll through these and see the compute units. You'll see mostly we're filling them, except the first slot in the rotation is sometimes a little under.
Mhm.
We can chat a little bit about that later and what that's indicating on this particular node. But here we've got a good string of hundreds. This duration is kind of the last one to talk about here. It's all of the data that we're showing in this UI is from the reference perspective of the validator producing it, or the validator that you're viewing. So here we're viewing this particular 8.2 validator. So all of this data, and a lot of it is going to be the same from any validator, right? The fees and the tips are part of the blockchain. So all of the
Mhm.
nodes have to agree on what those were. This duration is not some consensus value. It's a value that's local to this validator. And what it means is it's the time since this validator finished replaying the previous block until they replayed this particular block. So here, we've had slot 5404, and it might have finished at some particular time t. And what that means, it finished replaying on this validator at time t. So then the next slot after that was 5405, means it finished replaying at 317 milliseconds after t.
Mhm.
So some variation here is quite of expected, especially there's network latency and jitter is going to cause, occasionally you'll see kind of abnormally long, and then a few after it will be abnormally short. So here, like this first slot appears to have taken 511 milliseconds, but then the next one was 350. So they kind of smooth out a little bit.
So in this case, something like 00 looking to, reduce latency and also reduce jitter. Eventually, that something like that could be reflected here.
Yeah, as we reduce jitter, you'd want to see these all get smoothed to look much closer to 400.
Mhm.
And then potentially if the network agreed to reduce slot times, you could see the 400 go down to, let's say, 300 or 200.
Right.
Currently,
So the variation essentially that we're seeing, just to reinforce that, is based on latency and jitter
for the most part,
for
now
the most
different
part.
schedulers behave differently. The network kind of has a target block time of 400 milliseconds, and it tends to keep that somewhat well, but some nodes run fast and some nodes run slow. So as we mentioned over here, if your proof of history is running too slowly and you
Mhm.
can't produce the right number of hashes during your leader slot, you might see a node that just always takes longer than they should, let's say 600 or 700 milliseconds. They're going to skip.
There's like 1,000. There's like 1,100 at the top there, toward the top.
Oh, yeah. So not sure what happened here. He probably just took a long time to receive the shreds from the prior leader. so couldn't start the leader slot very quickly. You'll see it's the latency is usually on this first slot of the rotation, which is when the leader handoff happens. So they need to receive all of the data from the prior leader about what transactions were in their block, and then replay all of it, and then start their block. Whereas these last three in the rotation are, on the same node. So there's generally much less variation in these.
Right.
But yeah, so if the proof history is running slow, you might see a long block. Also, you would actually see consistently long blocks, not just in this first one. And I think the newest Agave scheduler sometimes will run ahead of the clock. So it'll produce blocks faster than 400 milliseconds. It'll do 350 or 300 just as a policy choice that they've made. If they can finish early, they will.
So again, coming back to this idea of how a validator can use this, validator can come here, select their slot, filter on their slots, and essentially look at the durations. They're hoping the durations are somewhere around 400 milliseconds pretty consistently, and that the compute units are pretty close to 100. And if either of those are skewing consistently far from that, then that could be cause for concern.
Yeah. And in Firedancer, we've fixed the slot time at 400 milliseconds. So every slot takes exactly 400 millis. The reason you see the duration is a little higher here is because there's kind of a gap between when we finish and start the next leader slot. It's typically around 20 milliseconds. But yeah, we try and shoot for essentially exactly 400 milliseconds of scheduling time.
Got
it. Another really useful thing for this duration, which we can't quite show because we haven't skipped any slots, but if you skip a leader slot, typically you can figure out exactly why by looking at the duration field. So the most often, I would say, cause of a skipped slot is that you fell behind. So someone published a leader block right before you, and for some reason you took a long time to replay it, and then you were still catching up when your leader rotation arrived, so you weren't able to become leader on time. And you'll see that kind of reflected in, you'll have a really high duration for some particular block, like it might be 3 or 4 seconds. So now our node is 4 seconds behind the rest of the cluster. And then you'll see a bunch of really short durations as we try and catch up. We'll be replaying really quickly. So they'll be like 150 milliseconds, 150, 150. But let's say we'll do 5 or 6 of those, and then it'll be our leader turn. We're still 2 or 3 seconds behind the cluster. So we didn't start on time and missed our slot.
Got it. And so you would see that by filtering on the skip slots. Which we don't have any of right now.
Yeah. We might be able to
yeah. Oh, I was going to ask if there's anything then we would trace back to the overview page, to the TPU waterfall. Like if we saw this happening in the duration.
So
would we see some of those too slow messages popping up here, for example?
No, because the too slow messages relate to the transactions we're receiving. So it's like our quick implementation was too slow, or the signature verification was too slow. That part of the pipeline is very separate from the replay system, which is what's causing us to fall behind.
Got it.
So if we had a full Firedancer GUI and we were also the ones replaying blocks, then maybe in that part of the GUI that doesn't exist, you would see some too slows happening, right? Because we took a really long time to replay something, but currently we can't show that.
Yeah, I'm just thinking, so my skip slots, it sounds like that's probably the best place to come to start troubleshooting something if you start to notice, I mean, obviously like an increased skip rate, but you can come here to my skip slots and start to get some information on the durations, and I'll possibly start to track back into why these slots are being skipped, which is some visibility, which is pretty useful. I think actually when we restarted our Firedancer node a while back, I forget what was happening. It was something with the 00 configuration, but we used this to troubleshoot. So we're skipping slots. And the latency was really high, which led us to understand that we hadn't reconnected back into 00 correctly.
Right.
So yes, I think
Yeah,
it's a good example of one of those useful tools, and one of those reasons that you put this together,
yeah,
because otherwise we're trying to evaluate logs, but this is a much easier and cleaner way and faster way to try and isolate problems.
yeah. And we may have some skip slots on another of our validators here. I'll see if it's come up yet. We're just rebooting this one. This could be a good way to kind of show some of those conditions.
Yeah, and I'm not sure if it made it into the recording, but actually the reboot progress was pretty interesting too.
Yeah.
So
Oh,
as
here we
you're,
go.
yeah,
Okay.
yeah, there are
Yes.
a couple.
Yeah. So this node we just restarted. You can see it has a pretty low uptime, 1 hour. It's got a lot more stake than the other node, so it's getting leader slots much more regularly. Here it's got one in 1 minute. The interesting thing is it skipped a couple of slots, and you might say, oh no, that's really bad. We'll go and actually investigate why. So what I can do is I can click these little warning signs up here and skip to that slot. And you'll notice something unusual right away. So the duration of all these slots right before it is 140 milliseconds. So that, you know, those leaders weren't producing blocks in 140 milliseconds. It means our node was very far behind the tip. And you can see we're here aggressively trying to catch up. Really all this is saying is actually we restarted the node at a bad time. And so when the node has restarted, it has to download a snapshot, right? And it starts a little bit behind the cluster. And so as it's trying to catch up here, it hasn't quite caught back up by the time it gets a leader slot, so it misses it. And then at some point here, this will stop catching up, and these will turn to 400 milliseconds when it hits the tip. At some point, if we keep scrolling, well, we still didn't catch up by this leader rotation, but by this one we did.
There it is, yeah.
Yeah, so here you can see at some point between those two, it's gonna go here. So we're at about 150, which is how fast we can replay when we're behind. We're replaying in 150 milliseconds, so we're catching up because the cluster's moving at 400. And then here, bam, we kind of hit the front of the cluster, and now we're just progressing at the same speed as everybody else. And so our very next leader slot after that, we make it just fine.
So why don't we click on the skip slots?
Yeah.
See what that looks like. Yeah. Okay.
Yeah, and you'll also see those in the overview here, and we can click on them here, but you'll see we didn't even become leader. So we've received a bunch of transactions, but in this case where our node knows it's behind because we restarted, it doesn't actually even try and produce a leader block. So you see we haven't even sent anything from pack to be executed.
Right.
If we fall behind once we've caught up for the first time, and we may not realize it, right? We may try and actually start a leader slot and it'll get skipped. In that case, you'll see we'll actually send some transactions further than this. We'll actually execute and produce a block that just the chain won't agree to land the block.
But in this case, you're still buffering.
Yeah. In this case, we haven't done that.
All right. Anything else on the leader schedule that you wanted to highlight? Otherwise, I mean, I think gossip's probably pretty straightforward, but for completeness, it's worth taking a look at.
Yeah, I think that's it for the leader schedule. Gossip we can look at. I guess we have this next leader slot up here is the only thing we kind of didn't mention. We have a skip rate that we show.
Yeah.
Here it's very high because we just restarted and skipped a bunch of slots when we did so. We'll just watch.
I guess the other interesting thing is you could filter this on any to see any validator as well.
Yeah, so just to pick like the highest staked validator, Helios, we can filter to their slots. We can see they're doing pretty well here, running Agave 2.2. You can also put a comma in here and we'll pick another highly staked node. Well, I don't know what. Oh, did I type it wrong? maybe they don't have any, here, put a comma and we pick, let's say our node, right? We're gonna see us kind of mixed in there with the earlier slots. So you can kind of select arbitrary validators this way.
Yep.